Right, so the other thing that we're going to look at in section 5.1 is not just the word random. We're going to define what we mean by probabilities. Right, so probability is used to measure how often random events occur. We use the frequentist approach to probability because probabilities are defined as relative frequencies or proportions. Right, so we could think about those as ratios, proportions, percentages, different things. So that's what we're thinking of when we're looking at probabilities. Right, theoretical probabilities are long-run relative frequencies at which an event happens after infinitely many repetitions. We can't actually do anything infinitely many times, so finding theoretical probabilities relies on theory. So if we think of the word theoretical, right, it comes from the word theory. Theory being mathematical theory. Right? Empirical probabilities are relative frequencies based on an experiment or observations of a real life process. Right? So this would be a case where we're looking at an experiment or a real life process. So in that first example that we looked at in this section, we talked about flipping a coin. If we were to actually flip a coin, right, a bunch of times, that would be an example of an empirical probability. Right? So why do we need both types? Empirical probabilities tell us how often an event occurred in an actual set of experiments or observations. Right? So if we are doing an experiment or observation, we want to think about our empirical probability. Theoretical probabilities, again, are based on theory. Right? Repeating an experiment infinitely many times is impossible, but that being said, that kind of ties directly into our next statement then. Since theoretical probabilities, right, are sometimes hard to compute, or we may not trust the theoretical probability, we can use empirical probabilities to estimate or test our theoretical probabilities. So as we're going through this chapter, in these first couple of sections, we're going to talk a lot about some different experiments, some randomness using our empirical probabilities from our experiments. And then as we move into the last couple of sections that we're going to go through, section 5.2 and 5.3, what we're going to do is we're going to be focused more on the theoretical part, right? The probabilities that are based on mathematical theory instead of a specific experiment. All right, so down at the bottom of the page, we do have one simulation. So let's use the random number table to simulate flipping a coin 20 times. An even number will represent heads and an odd number will represent tails. We can pick any row or column in the table as our starting point, as I mentioned in the previous page. So when we're using our big giant random number table, right, so we see this guy here, we can start anywhere we want to. In this particular example, I started in the 9th column of the 25th row because my nephew's birthday just happened recently, and it was September 25th. Right, so looking here, I have 20 digits in this little box, and we're going to use those digits for our simulation. Right, so we have 1, 7, 1, 1, 5, 0, 3, 4, 7, 9, 2, 5, 1, 3, 2, 8, 9, 4, 2, 1. We often see our digits kind of grouped both in our number table, kind of in these little lines, grouped in fives, just because that makes it kind of an easy way to work through that. Right? So an even number will represent heads and an odd number will represent tails. So I'm going to go through and label these heads and tails. All right, so even number is heads. So we have 0, 4, 2, another 2, 8, 4, and another 2. And then all the rest of the numbers are odd numbers. Those are going to represent tails. So then we're asked two questions. What is the theoretical and empirical probability from this experiment of getting heads when flipping a coin? All right, so theoretical probability is based on theory. So if we think about this, in theory, if we flip a coin, we should have a 1 out of 2 chance of flipping heads, right? So we assume a 1 out of 2 chance, so that our theoretical probability is 50%. Right? We assume a 1 out of 2 chance. All right, our empirical probability, well, that's coming from this actual experiment. So in this experiment, how many heads do we have? 1, 2, 3, 4, 5, 6, 7. Okay, so in our experiment, we had 7 out of 20 that were heads. If we change that to a percent, that turns out to be 35%. So again, our theoretical probability is based on theory. Right? So what we assume is going to happen if we think about a coin, right? We assume a 1 out of 2 chance. And on our actual experiment that we had here and our values that we picked from our number table, we had 7 out of 20 heads, which gave us an empirical probability of 35%.